This video talks about skeletal line structures for alkanes. So a skeletal line structure shows the bonds, but not the atoms in a molecule. Opposite of the condensed structure. The condensed structure showed the atoms, not the bonds. So each carbon atom in a skeletal structure corresponds to a point in a line structure. So look over to the right here. Your spheres here represent your carbon atoms. Each point in the skeletal structure is a carbon. So that right there is understood to be a carbon. That's a carbon, that's a carbon, that's a carbon, that's a carbon. So all of those are carbons. Your hydrogens, notice, they are not shown either. And I'll show you that in another slide, how we know how many carbons are there. So again, you're not labeling anything. You're not showing the atoms. You're not showing the hydrogen bonds either. That's omitted. Which way do you start the zigzag formation? It doesn't matter. Look at this example below. So we have C5H12. So where are my 5 C's? Each point. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The H's, again, I'll show you in another slide here. But back to my point, it doesn't matter if you start up with the zigzag or if you start down. It's the same thing either way. So that does not matter. So how do we know how many H's are in a diagram? It depends how many lines you have or how many bonds you have coming out from each point. So if we're looking at this point here, notice it already has 2 lines coming out from it. This line and this line. So that means we always need a total of 4 bonds coming from carbon. So that means I would have to have 2 H's coming out from there. And if we would actually draw the Lewis structure, you would see that there's an H here and there's an H here. But again, in a skeletal line structure, for simplicity, we don't draw that. It's just understood. 4 is always the number with carbon. So if I'm looking at this carbon here, there's only 1 bond coming from it, right? This bond right here. So I know that there are 3 H's right here. So here is a model, and it says write the skeletal line structure for the compound shown below. So I'm looking at my carbons. Looks like I have 6 of them. So this is hexane. So I want 6 points, 6 zigzag. So 1, 2, 3, 4, 5, 6. Notice your ends do count. So that's the answer right there. I started up here, right? I started going up. I can start down. Like that. I still have 6. 1, 2, 3, 4, 5, 6. Either are acceptable. So skeletal line structures for cycloalkanes. Cycloalkanes are really almost always written as skeletal line structures for simplicity reasons. But you're just going to draw the polygon that has the same number of sides as the number of C atoms. So again, if you have 6 C's, that resembles a hexagon. So you're going to draw a hexagon figure. So for cyclohexane, notice here's our 6 points. If we had 5 points, it would be a pentagon, etc. You'll see that here. So that's what those would look like for your skeletal structures. Again, it just takes a shape from geometry class. Each point, again, is a carbon. 3 carbons, 4 carbons, etc. Write the skeletal line structure for butane and cyclobutane. So the prefix but means 4. So I need 4 carbons. So for the skeletal for butane, there are my 4 carbons. 1, 2, 3, 4. And again, I started up there. You can start down. Same thing. Cyclobutane, it has to be in a cyclic form. So 4 would be a square. So I would literally just draw a square. And there are my carbons. Look how much quicker the skeletal line is than actually doing the Lewis structure. So that's the Lewis structure. If you just know that each vertex or each point is a C and there has to be 4 bonds around it, it's very quick. I know right away that has 2 lines from it, there has to be 2 H's there. So it's just a very abridged version. So what if we have something branched now, like we did in the last video? So you're still going to identify the main chain, the longest chain of carbon atoms in a row. And you want to draw that first. Ignore anything branched off. Draw the branch above the main chain when the branch point is up, and below when the branch point is down. It is incorrect to draw the branch point below when the branch point is up. So what does that mean? Right here. So notice here, I'm coming to a peak here. Because that point is up, this line is coming up here. I would not want to, that's at a peak, I would not want to draw it below there. That's incorrect. And here, if it's coming down to a point and I have a branch there, I'd want to draw it down. So that is what that is saying. Longer branches are written as zigzags in any direction. So you want to, when you're doing your branch, so here's your main chain. Notice I have a 2 carbon branch here, right? I have a carbon here and a carbon here. It doesn't matter which way I point that second carbon. Here it's pointed to the left, here it's pointed to the right. It can be any direction, that doesn't matter. So here is an example. So if you have 2 branches on a single point, like you do in carbon 2 here, you want to put them both going the same way. So what you don't want to do, so look at what you did here. Well, off the second carbon, we had a branch up and a branch down, but both of these went up because the point is going up. So that rule takes precedence. You do not want to do one up and one down because that breaks that other rule. So you just put both up, and that looks good. And then my other one here off the 5th carbon, I have 2 carbons. So that is why there's 1, 2 carbons there. Write a Lewis structure and a condensed structure for this skeletal line structure. Okay, so I'm first going to find the main chain of carbons. And I'm going to do that by labeling just with 1, 2, 3 the different vertexes and see which chain is the longest. So I'm going to start here. 1, 2, 3, 4, 5. Can I get more than 5 in any fashion? That's what I'm trying to check here. 1, 2, 3, 4, 5. No. 1, 2, 3, 4, 5. No. So it looks like that is the main chain. The 5th one is the main chain. So what I'm going to do is I'm going to put 5 C's, and that covers that. Now it looks like highlight in yellow here, off my second C, I have a C going up. So off my second C, I have a C going up. And then off my third C, I have two C's going down. So I have a C and another C. In my Lewis structure, I'm not drawing it zigzagged. That's only my skeletal structure. And then off my fourth C, I just have a C going up. So I got all of my C's. Now I'm just going to saturate them with carbons. As long as every C has 4 bonds, I know I am correct. So this C would need 3. This C would only need 1. This C would need 3. This C would need 1, 2, 3, 3, 1, 3. So you can see how messy that gets with a Lewis structure. And then for the condensed structure, that shows the atoms, not the bonds. So starting from the left-hand side, I have CH3. I'm going to do the main chain first. Then I have a CH. Then I have another CH. I have another CH. Then a CH3. So that's my main chain. Then off my second C, I have a CH3. Off my third C, I have a CH2, CH3. And then off my fourth C, I have a CH3. And that is my condensed formula.